All right, so that was a lot of definitions. So let's see some actual examples here, the kind of problems that you'll be asked to solve. So here's some symmetry examples. So first, example 1, is f even or odd, and what are its symmetries? F of x equals 2x squared minus 3x. So you have to test all these things. So notice first that even would be the same thing as symmetric with respect to the y-axis, because this is a function symmetric with respect to the y-axis. So that means I change x to minus x, right, in my formula. So f of negative x equals 2, the quantity negative x squared minus 3 times the quantity negative x. So you always put the negative x in parentheses, right? And then that simplifies to 2x squared plus 3x, which is not f of x. F of x is 2x squared minus 3x. And this is 2x squared plus 3x. And you can't manipulate it so that it's the same. So that's not equal. So the answer is no, it's not symmetric in the y-axis, and it's not even. So that answers 2 of the questions. F is not even and is not symmetric in the y-axis. Okay, so continuing, is it symmetric with respect to the x-axis? So here we would change y to minus y in the equation y equals 2x squared minus 3x. And you get minus y equals 2x cubed minus 3x. Solve for y equals negative 2x cubed plus 3x, and that's not the same. The signs are wrong, right? It's not the same as the original function. So the answer is no, it's not symmetric in the x-axis. Not symmetric with respect to the x-axis. Now I have one last thing to check, is it symmetric in the origin? Which is the same thing as, is it odd? Since it's a function, right? So I change x to minus x and y to minus y at the same time in the equation, the original equation. I get minus f of minus x equals negative 2, the quantity negative x squared minus 3 times the quantity negative x. And when I multiply that out, I get negative 2x squared minus 3x, which is actually, it's definitely not 2x squared minus 3x. The sign on the 2x squared is wrong, right? So that is not symmetric with respect to the origin, and it's not odd. So we ended up getting no for all 4 of these. It has none of these 5 symmetries. And, you know, most functions would have none of these 5 symmetries. So that's not that unusual.